Well, greetings everybody. So here's a problem from my math lab that I'd like to show you. It goes like this. I'm given a sequence by this formula, root 1 plus 1 over 16n to the nth power. Question, does it converge? If it converges, what does it converge to? Now, I would answer this question about whether the sequence converges or not by finding this limit. The limit is n goes to infinity as applied to the formula for that sequence as it was given. Okay, and there are lots of ways that you can find limits. I provided some formulas that you can use throughout this assignment on Canvas. You'll find them here on the same page where you probably found this video. All right, so let's go ahead and get started and see what we can do with this one. So I don't think it's a bad thing to look at the terms of the sequence and see if there's a pattern to it. It won't prove anything, but it could corroborate my answer and give me a little more confidence about what I'm doing. Plus, I don't think it's a bad thing to do anyway. So I'm going to find, say, the first 5 terms of this sequence. I let n be 1 in that formula, calculate and round to get the first term, let n be 2 to get the second term, and I kept going, and those numbers seem fairly consistent. They're not random, they're not all over the place. It looks like they're stepping closer and closer to about 1.31. Okay, who knows? But I definitely don't get the impression the terms are going to start trailing off from here or going in a random direction. So it seems reasonable to think it converges to about 1.031. This doesn't prove it though, but it's not a bad thing to look at if we're going to go further. Okay, now how would we prove that this sequence converges? By evaluating this limit. So here's what I would do. I think that just looking at that there is a formula on the list I gave you that seems like it might be able to help us with this one. And it's this right here. It says the limit as n goes to infinity of 1 plus a over n to the n power, a is some constant, is e to the a. I mean, of all these on here, this is the one that looks most like it applies to the problem that I have at hand. It doesn't look exactly like it, but it looks a lot like it. So I think that gives us a worthy goal to work towards. So, all right, that's my initial question. Does that formula apply to this? Well, not exactly as it is, but with a little rewriting, knowing some algebra and arithmetic, I think we can get it to work. So first of all, I noticed about this formula, it says, I'm going to just analyze the inside. I'm not worried about the root yet. Let's just figure out what happens to that interior expression as n goes to infinity. I noticed that it's got the 1, it's got the plus, but this formula doesn't say that the n down there can have a coefficient. It doesn't say that it can be 16n, okay? So is there some way I can fix that? Well, 1 over 16 times n is mathematically the same thing as 1 over 16 divided by n. If you want an analogy to that, look at this. I can take the fraction 1 over 6. I could say 6 is 2 times 3 if I wanted to. And that is mathematically the same number as a half divided by 3. That's just the way arithmetic works, okay? Now that's just an analogy to what I did over here, that I can take this 16, put it like that as 1 over 16. So just with that one small change, this formula does apply. And a, that constant right there, is 1 over 16. So I could say, merely from this formula that I've given you to work with, right there, just from that, I can say that the limit as n goes to infinity of this, that interior part of this root, is e to the power 1 over 16. Okay, now what about the root though? So if my goal from the beginning was to find the limit as n goes to infinity, as applied to this original formula for the sequence, as it was given, well, what I found is this expression inside the root as n goes to infinity will become e to the power 1 over 16. Now I need to find the square root of that. That's not an easy number, so it seems, to find the square root of. It's not like the square root of 25, which is 5. But if we think about roots as fractional powers, such as the square root is the same as the power 1 over 2, then I can use this one property of exponents to figure it out in simplest form. If I have a number and I raise it to some power n, and then in a subsequent step raise it to another power m, then I can reduce that to one exponent, the number a to the power n times m. And that's all that we're looking at right here. So e to the power 1 over 16, then subsequently to the power 1 over 2 is e to the power 1 over 32 by that property. And incidentally, e to the power 1 over 32 with some rounding is 1.03174. So that's what it converges to. And I think that's consistent with my initial observations. And that's the kind of thing I'd like to see. If I got a number wildly different from this, it wouldn't mean I was wrong, but it might make me double check some of my work. Okay. All right. So that's how we can do this one. Now, as you encounter other problems in the assignment, I would say, let's go back to this. Let's look at what we're given and let's see if there's some kind of formula on there that applies to what we have, even if it's not in an exact form. If it's close, we can try to rewrite it and then see if we can get it to apply from there.